we're going to have a look at identities today. Now, we shall use this simple diagram here. And down. This is X, this is Y, that is your R. Now, call this angle there theta. And then you will appreciate that if this is Y, that is parallel to that. And that means your X will be here. Now, the sine of R, the sine of theta, by definition is opposite, the side that is opposite theta, which is Y over the hypotenuse, and the cos of theta will be the side adjacent. Adjacent means next to the side which is next to this angle here. The side that's next to this angle is this one here. So it's X over the hypotenuse, which is R, and the tangent of theta is opposite over adjacent. The side that is opposite theta there is Y, adjacent will be X. Now, from those definitions, let's have a look at what happened to the equation of these two numbers. Divide the sine by a cos. From our alphabets here, this is Y over R divided by X over R. This can work out to be Y over R. We change the division sign to a multiplication, and we invert this fraction here. And this will give you R over R, or RY into RX. R will drop. You remain with Y over X. But you look on the far right, Y over X is the same as the tangent of X. Therefore, you can say the sine of an angle divided by the cos of the very angle is equal to the tangent of the very angle. Therefore, the cos of theta divided by, not the cos, but the sine of theta divided by the cos of theta, that gives you a tangent That's identity number one that you should know. And I've given you the proof thereof. We are going to have a look at the second identity. It says we said the sine of theta was opposite over hypotenuse, and the cos of the very theta is x over r. You can check that from what we have here. The sine of theta. The sine of theta is that, and the cos of theta is that. So let's see what happens if you square both sides. That will be the sine theta multiplied by the sine of theta, which comes from sine theta. If you square that, you have that. Now we know that we only square the ratio, not the angle. And from here, sine theta is y over r, and the sine theta is y over r. This will give you y squared over r squared. And the cos of theta squared will be x squared likewise over r squared. Let's look at the sum of this square to that. That becomes cos squared theta, the sum sine squared theta. This will equal to, the cos is there, is x squared over r squared, and the sine is there, is y squared over r squared. These fractions have the same denominator. We write only one. And on top, I have x squared plus y squared. Now let's go back to our initial diagram here. Now this is a right-angled triangle, and by Pythagoras theorem, hypotenuse squared is equal to the sum of the squares of the remaining sides. These are the remaining sides. Therefore, r squared is equal to x squared plus y squared. This is what you see here. Therefore, r squared over r squared, x squared plus y squared is equal to r squared. This is 1. Therefore, you can say sine squared theta plus cos squared theta is equal to 1. That's identity number 2 there. Now, what comes after this? Just the derivative of that. We said sine squared A plus cos squared A is equal to 1. I've swapped theta for A. Now, I can write sine squared A in terms of cos. I have transposed the positive cos, it becomes negative. So sine squared A is equal to 1 minus cos squared A. Now there is my cos. I can write cos squared A is equal to 1 minus, I transpose this time the sign comes this side. Let me rewrite that in a better way. That will be, our original is sine squared, let's say beta plus cos squared beta is equal to 1. Now this is my cos squared beta will equal to 1 minus the sine squared beta. Now I have managed to write cos in terms of a sine. On the top one here, I've written sine in terms of a cos. So that makes a good one for us to can handle exercises based on identities. Now, let's go to the first exercise. See what can we see there. First exercise, simple one. Simple one. A tangent of x multiplied by the cos of x. A tangent of x in terms of sine and cos, it is the sine of x divided by the cos of x multiplied by the cos of x there. This is over 1. Now you can see that the cos will cancel with the cos. And I remain with sine of x that's a lovely one. Your B will be 1 minus sine squared x over cos squared x, and then C will be 1 plus the cos of x into 1 minus the cos of x all over the sine of theta, not x. Now, let's go to B here. 1 minus sine squared x is this one here next to us. So that is cos squared x. Cos squared x divided by cos x. Remember, cos squared x is cos x multiplied by cos x. Divided by the cos of x. That will cancel. The answer becomes the cos of x. Let's look at number C there. C, if you look at the top part of that, if you look at the top part of that, if you look at the top part of that fraction, 1 plus cos, this is the same as A plus B into A minus a B. This is just the difference of two squares. And you know, from here, this becomes A squared minus B squared. So this one's going to be 1 minus 1 squared minus cos square theta over the sine of theta. 1 plus cos, 1 minus cos squared. 1 minus cos squared is something we've seen somewhere. 1 minus cos squared is the same as sine squared. This is sine square theta over the sine of theta. Now the answer remains to be the sine of theta. Let's go for a second leg of these exercises. The second leg, we are going to have the left-hand side and the right-hand side of an identity. We have sine cubed theta plus the sine of theta multiplied by the cos squared of theta divided by the cos of theta. This is equal to the tangent of theta. Now with this one is the left-hand side and that one is the right-hand side. If you look at this problem, the left-hand side is complicated as compared to the left, so the right. So the complex side is the one that you need to solve to make it equal to the simple side on the right there. Now, if you look well, the sign here is common. I take the sign out, sine theta. Here, there were 3 of them, so 2 are left, sine square theta plus, taking the sign out, I remain with the cos square theta. That is to say, sine cubed theta is equal to sine theta times the sine of theta times the sine of theta. This is sine square theta multiplied by sine. So that is the sine squared of theta multiplied by the sine of theta. So if I take this one, I remain with this one. This is what I remain with here. This is all over the cos of theta. Now, sine squared theta plus cos squared theta. If you go back to our work, sine squared beta plus cos squared beta equal to 1. So the rest of that will be equal to 1. So sine theta multiplied by 1 over the cos of theta. Going back to our initial identity, we have the sine theta over the cos of theta equal to a tangent of theta. Therefore, this is a tangent of theta. We can be happy that the left-hand side is equal to the right-hand side. The left-hand side is equal to the right-hand side. The next one will be sine. Let's look at this one here. Sine to the fourth power theta minus cos exponent 4 theta is equal to 2 sine squared theta minus 1. This is again difference of two squares where I have a to the exponent 4, b to the exponent 4. If I factorize that, it's going to be a minus b into a plus a b, but this is a squared. So that's what I have here. So this is the sine squared theta minus the cos squared theta into the sine squared theta plus the cos squared theta. And this is the left-hand side. Once again, we know this person here the same as 1. So we are left with that. We will be left with sine squared theta minus cos squared theta multiplied by 1. This is sine squared theta minus cos squared theta. But on the right-hand side, I have 2 times the sine squared theta minus 1. The right-hand side manifests only one trig ratio, which is sine. And the right-hand side have a sine and a cos. So maybe if we express this in one trig ratio, we might arrive at the answer on the right-hand side. Now let's see what happens here. We said sine squared theta minus. Writing cos in terms of sine, you can go back to page 3. Cos squared theta here is 1, cos squared beta here is equal to 1 minus sine squared beta. So writing a cos in terms of a sine, it's going to be minus 1 minus sine squared theta. Remove the bracket, which means stands for multiplication. Sine squared theta minus 1. Negative times negative is positive, and that will be sine squared theta. These are like terms. Sine squared a plus cos squared a is going to be 2 times the sine squared of the angle minus 1. Again, on the right-hand side, therefore, we have proof that the left-hand side is equal to the right-hand side. We can have a look at the last one for today. The last one. The last one will be the sine theta into 1 plus cos theta is equal to 1 minus the cos of theta into the sine of theta. Now, this is the left-hand side and that's the right-hand side. I'm going to take the left-hand side. I'm going to say the left-hand side. These are equally complex. So I choose whatever side. So I'm choosing the left-hand side. This is the sine theta over 1 plus the cos of theta. Now, I'm going to use a trick. This is what I'm going to use. I'm going to say 1 plus the cos of theta. This is the sine of theta. I'm going to multiply by 1. And look at my 1. My 1 is going to be fancy. It's going to be 1 cos of theta. 1 the cos of theta. This is a 1. And if I multiply by 1, I haven't done anything. 1 is an identity element for multiplication. Therefore, sine square theta into 1 plus the cos of theta. You multiply here by 1. My fancy 1 has taken that shape. 1 minus the cos of theta. Now, the top one is sine of theta multiplied by 1 minus the cos of theta. The bottom one, we see once again the difference of two squares rearing its head once more. We will have 1 minus cos squared of theta. And that will be sine of theta 1 minus the cos of theta. 1 minus cos squared theta, we know that this is sine squared theta. And then that will become, these are sine squared, so that one will drop 1 here, will remain with 1 minus the cos of theta over the sine of theta. If you look at the right-hand side, therefore, the left-hand side is equal to the right-hand side. I'm going to do the left-hand side in the same fashion. Now you do the left-hand side in the same fashion to prove that the right-hand side is equal to the left-hand side. Please do the right-hand side in the same way to prove that the right-hand side is equal to the left-hand side. And that will be enough for today. Bye.